What I have today is I have an LED string array tester. Um, this is a high voltage device, uses line voltage throughout the entire circuit. This is extremely dangerous, especially the way I have it right now. Everything's open. You know, it's not even in a box. There's nothing's insulated. I'm using perforated board, which is not really the best idea to use on a project like this. As you can see from the bottom here, what I've done is I've removed one row of padding of these copper paddings that are surround the terminals and the components, because each component is carrying the line voltage. And especially here at the input of the socket, there's 120 volts line right there. And where the capacitor is, this thing will charge up to 400 volts. So should you, or the capacity is 400 volts, it'll charge to about 230, 240. So should you accidentally touch anything on here prior to the output, there's a very good possibility that you'll get the worst shock of your life, let alone anything worse than that may happen. So this is not really the safest method of making something like this, but I put it together to show you guys. You must keep in mind that safety is number one concern on a circuit like this. It should actually be in a box. It should be insulated, should be isolated from chassis, and so on, because there's no isolation from the line. All right, everything is direct here, so it's not exactly the safest way. You know, I'll keep saying that throughout the video. But nevertheless, I want to show you how this thing works. Now, what this thing does is it'll check LEDs, either individual or a string array of LEDs, such as the type that they use in LED TVs, where they use the string of LED backlighting for backlighting, and they always go bad. So a lot of guys online are actually making circuits like this or buying them already made in order to test those LEDs, but this is how it's made. And I'm gonna break this down in a little while, and I'll show you how it's actually built. Now, this unit that I actually am showing you right now is you could use in Europe as well, because it'll run on 220 out there, and you can use it in North America. It'll run on 110 AC as well. So that's why the component values are kind of high. Now, you can see here that I used high wattage resistors. That's just for, you know, caution. I don't want anything burning up here. I want the components to be able to take any brunt force that they would go through, and that's the reason I used high wattage types. I had them available, so why not? You know what I mean? So anyways, let me show you exactly how this thing works. I'm gonna just bring in an LED here. I'll bring in my meter, here, and try to get this all in one shot here. And I've got my AC cord. So now my AC cord is actually unplugged, because I don't want to take any chances here. Yeah, hold on a sec. Let me check to make sure it's unplugged here. Yeah, it is unplugged. So I'm going to plug this in right here. Okay, that's in. Now the output is right here. I'm just going to turn my meter on to DC. This is a DC output. I'm going to connect positive is on this side and negative is on this side. And you'll see that this thing will charge up pretty quickly when I plug the power in. So let me grab the cord. All right, here we go. I got my meter set on DC, and here we go. Okay, now you can see how quickly it'll charge up over 200 volts, and that charge is being stored on the capacitor right here. Now this thing will charge to about 220, between 220, 230, possibly 240. Now, this circuit does have one feature in here that must not be eliminated. You must absolutely make sure that it is included, and that is this resistor right here. This resistor is a bleed resistor, and the purpose of this resistor is to discharge this capacitor once you remove the power from it, okay? Otherwise, that capacitor could be a lethal component that's left in here should you accidentally put your fingers across it. Now, the voltage is at 230. Now I'm going to take the LED. Where did the LED go here? Give me one sec, guys. Oh, here it is, right underneath. Got pretty lucky there. All right, now, this is just a regular 2-volt LED, high brightness type. This side here is positive, this side negative, so anode goes to this side. Now, I'm going to try and connect this carefully just to get it lit, and I want you guys to keep an eye on the meter once I touch this. If I can hold it in place here. Wow, having such a hard time here. Okay, hold on a sec. Okay, there the LEDs. All right, the LED is on. Actually, let me use some tweezers here. Maybe I have better luck. All right. Okay, the LED's connected. You can see the lights coming on, and if you look at my meter, oops. All right, the LED, finally it's on. All right, now if you look at my meter, it says 1.85 volts, 1.857 or 1.86 roughly. And that is the voltage drop across the LED, all right? And the LED is on, as you can see. But now, as soon as I remove it, you'll see that my meter will go back up to over 200 volts. Now, ideally, this is also, obviously, LEDs don't take that kind of voltage, but because it uses these resistors in line, the current is very, very small, and most of the voltage drop will drop right across the LED at that current, or across the resistors. So this can also be is also used to check LED array strips, such as the type that they use in the LED TVs, backlighting. And a lot of guys are actually building or buying circuits of this type in order to be able to test those systems. But this is how it's made. So what I'm going to do is, I'm not comfortable with leaving everything connected while I'm making this video, so I'm just going to remove the power here, and you'll see that the voltage will drop kind of drastically, which is necessary because you want the voltage to go away from this capacitor as soon as possible. So we're just going to wait for that until it gets down to a safer level. Get down to about 5 volts. All right, that should be good. So now I'm going to remove the AC cord just in case, and remove my meter here. And we'll get this out of the way. All right, now, as you can see, this circuit is not that extravagant. It's actually pretty simple to build. You just have to be very careful because it does use line voltage. And of course, this makes it very dangerous to have it open like this. I would not recommend it that you guys build it the way I did. It should be built in a more secure fashion, insulated, away from being able to grab the board itself, because everything here is live, and it's I mean, you can have dire consequences if you make any mistakes or touch any part of the circuit while there's still power in it. So especially across the capacitor, and especially even though there's no power, if that charge remains on the cap, or if the power is still plugged in here and you somehow miss that and accidentally touch the circuit, I mean, the outcome is not going to be favorable. All right. So, anyways, first priority of this type of circuit is safety, and you have to keep that in mind at all times. So now I did have a diagram for this unit, but I actually don't remember where I put it. So what I'm going to do is I'm going to just grab a piece of paper here, and I'm just going to back engineer this for you guys, because this is actually very simple if you look at it. So back engineering this thing is not that difficult. So let me do that right now. So obviously we have an AC plug right there. So there's your AC. And the top part, which is there, goes to the capacitor and that resistor. So this will go to a cap. This will go, which is parallel to with a resistor. The value of the resistor, as I can see, is blue, gray, yellow. That's 680K. The value of the capacitor is 334. 334. Now in microfarads, this would be 0.33 microfarad. And that part right there goes into the bridge rectifier, the 4 diodes. So I'm gonna display the 4 diodes in this fashion because it's easier to understand this way. All right, you can see here I got the cathodes together, top and bottom, and I got the anodes together, top and bottom. Where the anodes are, this is negative. Where the cathodes are, this is positive. So the other side of the bridge rectifier goes back to the AC line, but before, not directly, it goes through this resistor. This resistor is brown, red, black. That's 12 ohms. So we'll just connect that like this. 12 ohms. 12 ohms basically acts like a fusible resistor. So that's basically your fuse for the line. Then the output of the diodes goes directly, the positive side, which is right here, goes into the capacitor. That's the electrolytic. Oh, these diodes are your standard 1N4007s. ACN is 120 volts AC. The value of this capacitor is 10 microfarad at 450 volts. That's important. You have to no less voltage than that, because the peak-to-peak voltage gets pretty well very close to that. And let's see, the negative of the capacitor goes back to the bridge rectifier anode side, so that would be right here. Okay, now the output of the capacitor goes to 10K resistor, or actually I forgot the most important one, which is this resistor right here. This is called the bleed resistor. And that bleed resistor goes directly across the capacitor, like so. And you must absolutely have that in. That is mandatory. Do not remove that resistor. Do not forget to add that resistor, because that is your bleed resistor. And this is for safety issues, okay? And mandatory, must be in circuit. The value that I have in here is 220K, and that will bleed off the charge of this capacitor. Once you remove the AC cord, that'll bleed off the charge through the resistor, and it'll reduce the value of this capacitor to literally zero over time, and that will keep you from getting shocked should you accidentally touch it. All right, so absolutely mandatory that resistor be in circuit. Okay, do not leave it out and do not remove it. Then the output of that goes through another 10K. This is your positive output. And the negative, which is this one here, that comes down to diode, actually. So the negative terminal also goes through a 10K, and before it gets to the negative rail, it goes through a diode. Okay, to keep the polarity correct at the output as well. And here's your probes. Now, these probes right here, positive, negative, is what you see here. This is what goes out to test your LEDs or LED strips. And you can also connect your voltmeter across here, which will show you what the voltage is once it drops to whatever you're testing. And anyways, here's the circuit for it. All right. Now, again, I will say this is not, what you see here is not the common way of building these things. You do not build this kind of circuit on a perf board the way I did. Despite that I did it, I did take some safety precautions as far as eliminating one row of solder pads here in order to keep the components as far apart as possible, because we don't want any accidental shorts across any components for any reason whatsoever. But again, I'm going to stress that this is very dangerous the way I have it. All right, and it's also a very dangerous circuit overall because it should actually be in a box. It should be in an insulated box. It should be everything about the circuit is live from beginning to end, and so it's not a safe procedure to do it the way I did it. Okay, but nevertheless, here it is, and it does work. I showed you the function of it. So this is just another little project that I build. With my other ones to keep in the shop, just in case I'm in need of it to do such tests, because I also have an LED TV that I had problems with backlighting and I needed to build it. Now everybody online is building these things, they're buying these things, but guys, if you wish to build it as I showed you here and as you see in the diagram, please keep in mind safety has to be number one priority here. All right, because you are dealing with live 120 volts. There's no isolation on this thing at all. Take every precaution possible to keep it safe, because the result is not going to be in your favor. If anything should go wrong, we won't want any accidents. All right, so as you can see, even the AC plug over here, because I just soldered it with wire into the strip, I actually had to secure it with this very stringent copper wire, number 14 copper, which I actually soldered to the board. So that keeps the plug itself from moving around. But really, I'm going to remake this at some point and do it properly inside of a box, everything isolated and so on. But I just did it this way. It still works, and it's easier to show you guys, and it's easier to show you guys on diagram. So if you guys like this video, please give me a thumbs up. If you have any comments, leave it in the comments section, and I'll reply as soon as possible. And also, do not forget to subscribe if you have not done so. And I will keep these type of things coming. And I will also give you some diagrams so you guys can build it yourself. I'll say, okay, instead of going out and buying it, this is how actually simple it is. And also the components, I just wanted to reiterate that the power capacity of the components, they don't really have to be this size. I just use this size because this is what was in my stock, and I decided to use them because they were the right values, and they're beefy enough so that if anything should happen drastically to this project, these resistors will not burn up or short out or whatever. They're big enough to handle any kind of power load. So I just did it for that reason, but really that's not necessary. Okay, I just kind of really went overboard here. So I can't even explain the reason, I just decided to. That's it. So anyways, guys, thank you very much for watching. Until next time, and yeah, stay tuned. I got some good ones coming up. I got one that has to do with mechanical panel meters. I think you might be interested in this. And in that one, and I'll post that one up very soon. This one here, I'm pretty sure also you guys might be interested in. It's something that comes in very, very handy, especially if you have if you deal with LEDs and LED strips, which seems to be a common thing nowadays, especially with backlighting for LED TVs, and also some hobby stuff. You know, a lot of them flashlights. They're all using LED displays. Even regular lighting in your house, they're all using LED strings. You know, so this is one circuit that you should actually put together. It'll come in out of all the equipment that you guys might have. This is probably going to be the most handiest one you'll ever have. So there you go, guys. You're welcome to it. And again, thanks for watching. Subscribe and catch you next time. Have a nice day, and thank you very much for watching. So long.